Hey, welcome back. Let's take a look at hybridization. So we've talked about orbitals, such as the s orbital, and we have also talked about orbitals such as the p orbitals. Notice I've drawn the shapes here. Now we talked about them as if they're in layers, meaning that we must get to the s orbital first and then the p orbital, so that the p is on top. But in actuality, they're actually hybridized, meaning they are not separate, but they are together. So instead of the sphere and the separate dumbbell shape, they're actually blended together like this. So instead of having layers on the top and bottom, they're actually really side by side, energetically speaking. The first hybridization we're going to look at is that of the sp. Since there are two orbitals here, we're going to have atoms that are involved in bonding. So one of the categories I will have is atoms that are bonded, and also electron pairs, which can also occupy the orbitals. These two values, or these two concepts, will, in the end, tell me what the geometry was. These are geometries that we already went over in the VSEPR section. So since there are two orbitals here, an s and a p, I could have two atoms bonded and 0 lone pairs, and this would result in a linear geometry. Now the other combination that could be is one atom bonded and 1 lone pair, and this would still result in a linear geometry because the lone pair would not be pushing down or affecting the bonds. Next, let's look at sp2 hybridization. Notice there are 3 orbitals here, so I could have 3 atoms bonded. I could have 0 lone pairs, and this would produce a geometry that is trigonal planar. I could also have a combination in which I had 2 atoms bonded and 1 lone pair. The lone pair here will affect the bond and cause it to be bent linear because the lone pair will deflect those 2 other bonds. The last combination is 1 atom bonded and 2 lone pairs. And this will end up just being linear because the lone pairs, once again, will not affect the other bond. Let's take a look at the sp3 hybridization. There's 4 orbitals, so I can have 4 bonded atoms, 0 lone pairs, and get my unique shape of a tetrahedral. I can also have 3 bonded atoms, 1 lone pair, and I will push that plane down and get a trigonal pyramidal shape instead of a trigonal planar because of the lone pair on top. I can also do 2 atoms bonded and 2 lone pairs. The 2 lone pairs will push the other 2 down into a bent linear shape. And lastly, I can do 1 atom bonded and 3 lone pairs, giving me a linear shape. That's it for hybridization. I'll see you next time. Bye-bye.